Good morning, everyone. In this section, we will discuss about the advanced encryption standard algorithm. This is called the AES. AES is specification for the encryption of electronic data. In this algorithm, basically we have used the three block cipher. One is the AES 128, AES 192, and AES 256. Each cipher encrypt and decrypt data. There are 10 rounds for 128-bit key, 12 round for the 192-bit key, and the 14 round for the 256-bit key. So simply, basically, this is the basic introduction of the AES requirement. In the AES, basically is the replacement of the DS algorithm. It is the more faster, stronger from the DS. It is the 16 times faster from the triple DES algorithm and the implement in the Java and also in the C. So simply this is the AES. After this, we will discuss on the what is the AES. AES basically proposed by uh, Ridgman and Damon. This is called the Ridgendale in the 2001. AES specification use the same three key site alternative but limit the block length of 128 bits. Uh, uh, so this is a simple AES and it is also follow the fiscal cipher structure that is used in the DS algorithm. Uh, advanced encryption standard uh, basically includes some steps just such as the set of round key from the cipher key, the initialized state array and the initial round key to the starting state array, perform round in the round 1 to 9, and, and execute final round corresponding ciphertext to the final round step. There is some simple step that is included in the AES algorithm. Basically, uh, a single round divided into four parts. There is a sub byte, shift row, add round key, this add round key, and the last is the mix column. So this is basically a single round. So first we discuss about the uh, what is the simple process of the advanced encryption standard. So in the first round we use the sub byte. This is called the substitution byte. This is the part of the encryption. What is the substitution byte? This In substitution byte, basically 16 input bytes are substituted by looking up a fixed table. The table is the scopes given in design. The result in a matrix of 4 row and the 4 column. So this is the byte substitution or sub bytes. The shift row, each of the 4 row of the matrix is shifted to the left. Any entries, any entries and the fall off are re-inserted on the right side of the row. The shift is carried out as follow. The first row is not shifted, means there is no change in the first row. Second row is shifted 1 byte uh, position to the left. Third row is shifted 2 position to the left, and the fourth row is shifted 3 position to the left. So the result is new matrix consisting of the same 16 bytes but shifted with respect to each other. The diagram show that how to shift the uh, bytes 1 to 3. The example show that there is no shift in first row, one shift in second, two shift in the third row, and the last in the three shift. So this is the byte uh, shifting. And that is the mix column. In the mix column, each column of 4 bytes is now transformed using a special mathematical function. This function takes as input the 4 byte of one column and output 4 completely new byte, which replaced the original column. The result is another new matrix consisting of 16 bytes. It should be noted that this step is not performed in the last round. This diagram shows the mix column, how to mix the column. After this mix column, we add the round key. In the 16 byte of the in the round key, the 16 bytes of the round key are now considered as 128 bits and are adjoined to the 28 bits of the round key. If this is the last round, then output is the ciphertext. Otherwise, the resulting 128 bits are interpreted as 16 bytes and we begin another similar round. So if we use the 128 bits, then the total number of round is the 10. Use the 192 bit key, the total number of round 12, and use the 256 bit key, the total number of round is the 14. So this is the add round key. After this, this diagram shows how to add the add round key. In the last, this is the show the single round of the AES. There is the sub byte, shift row, mix column, and add round key. So this diagram this diagram shows the internal structure of the single AES round. What is the Aes key expansion? In the Aes key expansion algorithm takes as input forward 16 byte key and produce a linear words of words, providing a 4-word round key for the initial add round key stage, and each of the 10, 12 and 14 rounds of the cipher. It involves copy the key into the first group of 4 words and then constructing subsequent group of 4 based on the value of the previous and the fourth backwards. The first word in each group of the 4 gets special treatment with rotate S box and XOR constant to previous word before XORing the one from back. In 256-bit key using 14 round, there also an extra step on the middle word. This is the Aes key expansion. This diagram shows the Aes key expansion means how to expand the key. In this, it shows group of 4 bytes in the key assigned to the first 4 words. Then calculation of the next 4 words based on the value of the previous 4 words, which is repeated enough times to create all the necessary subkey information. And the key expansion rationale, the key expansion rationale basically designed to resist the known attacks. And the design in the what is the design criteria include in this design criteria include knowing part keys insufficient to find many more, invertible transformation, fast on wide range of CPUs, use round constant to break symmetry, diffuse key bit in round key, enough non-linearity to hinder analysis, and the simplicity description. This is included in the design criteria. After this, what is the AES decryption? AES decryption is the just reverse process of the AES encryption. The sequence of transformation for decryption differ from the encryption. Although the form of the key schedule encryption and decryption is the same, this has the disadvantage that 2 separate software or firmware modules are needed for applications that require both encryption and the decryption. There is, however, an equivalent version of the decryption algorithm that has the same structure as the encryption algorithm with the same sequence of transformation as the encryption algorithm. To achieve this equivalence, a change in key schedule is needed. By constructing an equivalent inverse cipher with steps in same order as an encryption, we can derive a more efficient implementation. Clearly, swapping the byte substitution and shift row has no effect. Since work just on bytes, swapping the mix column and add round key steps require the inverse mix column steps by applied to the round key first. This makes the decryption key schedule a little more complex with this construction, but allow use of same hardware or software for data and decrypt the computation. Basically, the order of AES decryption is the add round key, mix column, shift row, and the byte substitution. But in the order of the encryption is the byte substitution, shift row, mix column, and the add round key. So this is simply AES decryption. The diagram show the AES decryption. Where is the add round key, inverse subbyte, inverse shift row, inverse mix column, and the add round key. So this is simply the AES decryption. After all, we discuss about the difference between the mm, DS and the AES. So first is the definition. The definition AES is the Advanced Encryption Standard, and the DS is the Data Encryption Standard. Key length, basically three key length in the AES 128 bit, 192 bit, and the 256 bit. But in the DS only, key is the like, key length is a 56 bit key because 8 bit used for the parity. Number of rounds, the number of rounds in the AES is 128 bits for 10, 192 bit key for 12, and the 256 bit for 14. But in the DS round is fixed. This is the 16 round. In the over using the network, AES structure is based on the substitution and the permutation network. Where is the DS structure is based on the physical network. In the security, AES is a de facto word. Standard line is more secure than DS. DS is weak, and the triple DS is more secure from the DS. Rounds, byte substitution, shift row, mix column. The key addition is the round of and the round, and the DS is the expansion, XOR operation with round keys, substitution, and permutations. Size, basically the size of plain text is the 128 bit in AES and the 64 bit plain text in the DES. Derived from AES derived from the square cipher, and the DS derived from the Lucifer cipher. And the last is the designed by AES was designed by Vincent Richman and John Redman Damon. This is called the Reason. And the DS designed by the IBM. Some known attacks. There is no attacks available in the AES, but in the DS attack, the brute force, linear cryptanalysis, and differential cryptanalysis attacks in the DS. Thanks everyone.